my second video in my module on geometric sequences, in which we're going to focus on graphing geometric sequences as well as finding a rule for the nth term of the sequence. So let's go ahead and get started. Really quickly, just a review of what we mean by geometric sequence. We say these are any sequences in which there's a common ratio from one term to the next. By common ratio, recall that we mean it is a common like multiple thing you're multiplying by to get the next term. So this is like times 2 times 2 times 2 times 2, so on and so forth. We say that things like this, you could find the nth term of the sequence using this rule. We say the nth term is always equal to the first term times the common ratio to the n minus 1th power. And so the reason why I bring this up is because our goal here is to be able to, first of all, say given one term of a sequence, we say the third term here is 5, and a common ratio r, could we first write a rule for the nth term of the sequence? And so what I want us to recognize is if we were going to write the rule for the sequence, we would need two things. We need the first term and r. And in this instance, we have r. The unfortunate thing is we don't have the first term. However, this information we've been given here, this a3 equals 5, that is like an an, and we can actually go ahead and plug it in out here. So what we're actually going to do is we're going to plug into this equation here. We say a sub n equals my first term, which I don't know, times r. Now r we know, to the n minus 1. And so what this looks like is this right here. We say a sub n. Now a sub n equals 5. I'm getting this from right here. And this is true when n equals 3. So we're going to put a 3 up here for our n, and we have a base of 2. So all we did was we plugged in everything we knew. Now we're going to go solve for the one thing we don't know, which is a1. So we have 5 equals a1 times 2 to the 3 minus 1 power. In other words, times 2 squared. So we get 5 equals a1 times 4. And dividing both sides by 4, we end up with this. a1 equals 5/4. So in terms of the rule for this thing, a1 equals 5/4. So let me move this over here. We say a1 equals 5 divided by 4. Now we know a1 and we know r is 2. We could write a rule for this. We say a sub n is equal to the first term, which is 5/2, times the common ratio of r to the n minus 1. So when somebody says, hey, let's go make a graph of the first 6 terms of the sequence, what we do is we'd actually write out the first 6 terms of this sequence. And so in order to find these, we'd actually, one way to do it is we could make a table. We could say a sub n and n, so our first term, our second term, our third term, fourth, fifth, and sixth. There's an easier way to go about this, but we say plugging in 1. So now if my rule is this, if I plug in 1, we say a1 equals 5/2 times 2 to the 1 minus 1. In other words, 2 to the 0. And 2 to the 0 is 1. So like 1 times anything is itself. So we could get 2 to the 0, which is 1, times 5/2. This just comes out to be 5/2. So we say 5/2. The cool thing about this is we already know the r values. In other words, I already know what's going to come next. We'll take the initial value times 2. And if I take that times 2, I just get 5/2 times 2 is 5. Times 2 is 10, times 2 is 20, times 2 is 40, and times 2 is 80. So if we wanted to graph this sequence, we'd say, all right, maybe I'll spread this out a little bit here. The first 5 terms of my sequence, we say 1, 2, 3, 4, and 5. We'll spread it out this way, 1, 2, 3, 4, and 5. Now remember, we're putting n down here. These will be up here. These will be our a sub n. And so since I get to a maximum height of 80, we should probably go up by, let's see this. If I made this like 20, 40, 60, 80. If we go up to 80 this way, let's see, what are we going by here? We've got 5 notch marks up to 20. Each of these notch marks is 4. So our first term here was 5/2 or 2.5. That's like about halfway up to 4 here. So it would be about right here if this is 4. Okay, so 2.5. We have 2 comma 5, so over 2 up 5, which is a little bit above here. And we say, okay, if I wanted to go to 10 next, so my third term is 10. So 10 is directly, halfway the way there. We say there's 10. And we say, all right, 20 is the next one, so my fourth term is 20. And my fifth term is 40, so my fifth term is 40 here. And then we're going to double this height when we get to my sixth term here. But essentially, here's what you're seeing is our geometric progression. Of course, you wouldn't connect the dots because, recall, we have a first term, a second term, third, fourth, and fifth, and sixth term, but we don't have anything in between those. So, for example, I don't have a 2.5th term, okay? So we're going to try this again really, really quickly. If I give you a term of a sequence, we say a4, the fourth term is 3, and the common ratio is 3 here. Then let's go find the rule for the nth term of the sequence. We say an equals a1 times r to the n minus 1 power. So this being said, let's go ahead and plug in what we know. So we know an in this case we say is 3. So we say 3 is what an equals. We don't know a1. We do know r. R in this case is 3. And this is to the n minus 1 power, where our n in this case, recall our n is 4. When n is 4, we got an a4 of 3. So when this is 3, this up here is a 4. So we simplify this a little bit. We say a1 times 3 to the third. In other words, 3 equals a1 times 3 cubed is 27. And if we divide both sides by 27 here, and this can be simplified, we say, well, then a1 equals 3/27, which is the same thing as 1/9. So we have a first term now, and we have an r. So let's go and write the rule for this. We'll put it in blue. We say an is equal to my first term, which is a 9th, times r, which is 3 to the n minus 1. So here's our rule right here. And in order to kind of see what this looks like, we call this some sequence b of n, and this is n. We have 1, 2, 3, 4, 5, and 6. We could say our first term, when we plugged in 1, we get 1 minus 1 here, which is 0. And 3 to the 0 is, well, 1. And 1 times 1/9 is 1/9. So we get a 9th. We already know that this r is times 3, so we say times 3. If we just keep tripling these each time, we'll get the next one. So 3 times a 9th is 3/9, which is a third. 3 times a third is 3/3, which is 1, times another 3 here. 3 times another 3 is 9, times another 3 is 27. So again, to graph this, we'd say we could probably go 1, 2, 3, 4, 5, 6. Actually, I graphed it incorrectly over here. I did 1, 2, 3, 4, 5, 6. Sorry. If we spread it out 1, 2, 3, 4, 4, 5, 6 this time and do it like I said I was going to do it, we went up to 27, so we probably get away with going by 5, go by maybe 2. So we say 2, 4, 6, 8, 10. 2, 4, 6, 8, 20. 2, 4, 6, 8, 30. And so our first term was a 9th. That's barely off the ground. Let's go and switch colors here. So our first term was a 9th. If we're going by 2s. A second term is a third, also very close to the ground. Third term was 1, so that's like halfway between 0 and 2. Our fourth term here is 3, so that would be finally at a height of this. Fifth term is 9, so our fifth term would be up at 9, so 2, 4, 6, 8, 9 would be about right here. And then our sixth term is 27, so that'd be like right here. So here's our geometric progression and how you graph them.